Good morning, champs. Now let's solve our first real flow problem. We will apply the energy balance to a turbine, step by step. Imagine steam flowing through a turbine. It enters at high pressure and high temperature and leaves at lower conditions. As it flows through, it causes the turbine to spin and produce power. We are given the mass flow rate, the inlet and outlet conditions, and a small heat loss. And we want to find the power output. First, we identify the system. This is an open system with mass flow. So we start from the general energy balance. The change of energy inside equals heat, work, plus energy carried by mass in, minus energy carried by mass out. Now we simplify. The turbine operates in steady state. That means nothing changes over time. So the energy inside the system stays constant. This means the change of energy is zero. So energy going in must equal energy going out. The equation becomes much simpler. Heat plus incoming mass energy equals work plus outgoing mass energy. Now we rearrange this to solve for the power. We see that the power comes from two contributions: heat transfer and the difference between inlet and outlet enthalpy. So the key idea is simple. The turbine produces power because the fluid loses energy. Next, we go to the steam tables. We read the enthalpy values at the inlet and outlet states. These values are not calculated here. They are taken directly from the tables. Once we have these values, we plug them into the equation. We multiply the mass flow rate by the difference in enthalpy and include the heat loss. This gives us the power output. Physically, this means the steam enters with high energy, leaves with lower energy, and the difference becomes mechanical work. Some energy is also lost as heat, so the turbine converts the energy carried by the fluid into useful power. And that's the key idea for all flow systems. Power comes from the change in enthalpy.